Good day, students. Today I want to talk about the syllabus code, Cambridge syllabus code, chemistry at O level or Cambridge IGCSE syllabus code 0620. Today I want to tackle this topic on isotopes. As you can see on the whiteboard, I have put about three atoms of the same element, magnesium. What does this tell you? It tells you that atoms of the same element may not be necessarily the same. They can be different. For instance, you notice that the number at the bottom is the same, 12, 12, 12. Okay? But the number at the top is different, 24, 25, 26. Now, from our previous studies of the periodic table, we now understand the notation that is used on the periodic table. The number at the top is always the mass number, but the number at the bottom there is the atomic number. So the information that we are getting from the information on the whiteboard is the fact that the atomic number of the three atoms of this magnesium is the same, but the mass number is different. And from our previous session, we saw that if I take an element, I'll just take the first one, for instance, magnesium 24 and 12. If I subtract the mass number and the atomic number, I will get the number of neutrons. So it means in this one, I am going to have 12 neutrons. In the second one, I'll be having 13 neutrons. And in the second one, I'll be having 14 neutrons. So what does this mean, students? It means that when we are looking at isotopes, they could be defined as atoms that have the same atomic number, different mass number, or you could say different number of neutrons. So atoms of elements are not necessarily the same. But what do we find when we go out in nature? If we go out in nature, maybe you're going to find out that out of a population of magnesium atoms, 80% of them will be magnesium atomic mass, 24. Out of a population of magnesium atom, 10% will be magnesium, 25. And out of the same population, maybe 10% will be magnesium, 26. Which means the most common form of magnesium we find out there is magnesium 24. So you could get a question at O level or at AS. AS, I'm referring to chemistry 9701. You could be asked, how would you find the relative atomic mass of these three atoms of magnesium? It's a very simple mathematical procedure that we can do here. Because we have been told that, okay, 24, the atomic mass of magnesium 24 is 80%. What you simply do is this procedure, you could say 80%, okay, out of 100 multiplied by 24, you close your bracket here, and then you say, okay, the magnesium mass number 25 is 10%. So I'm going to say 10 over 100 times 25, and I close the bracket, and again, you're going to say 10% of the population of magnesium 26 is found in nature. If you perform this calculation on your calculator, maybe you are going to find the number 24.3, which means this 24.3 is now the relative atomic mass of magnesium. We've taken into account the relative abundance of each magnesium atom. And in this way, we are in a position now to appreciate the fact that although we are talking of magnesium element, not all of them are going to have the same atomic mass. And this number here is actually a reflection of the fact that it's 24.3. And it's actually true because it's closer to the atomic mass which is of highest relative abundance. Okay, so this is the information that we can get from isotopes. The atomic number is the same, meaning to say the proton number, in all the cases, the proton number will be equal to electron number, okay? And the moment you talk of electron number, you are talking of electronic configuration. The moment you mention electronic configuration, you are now into the chemical reactions. So what could be similar about these three types of magnesium atoms is that their chemical properties are going to be similar because they have the same number of electrons and the electronic configuration is the same. And because the electronic configuration is the same, most likely they are going to have similar chemical reactions. And if you were to look at the electronic configuration of magnesium, if you can recall, it's 2, 8, 2. Okay? Meaning to say magnesium is in group 2 because the relationship is always the valence shell, the number of electrons in the last shell is equal or is equivalent to the group number of the element in most cases. So these three isotopes of magnesium, all of them will be in group 2. But because they have different mass numbers, they are going to exhibit certain properties which are different. Some of them, of course, will be radioactive, okay? And they will be having what we call radioactive isotopes. And then they actually begin to be used in other situations like treatment of cancer, radiotherapy, and many other uses where we need radioactive isotopes. But the main aim of today's lesson was to show you that atoms of the same element may be different, having the same electron number, proton number, but the numbers at the top might be different. And because it's different, then we are going to have different number of neutrons. I'll see you in the next video where we are going to look at the periodic table, how we classify elements, and also how we can do chemical bonding for covalent bonding, ionic bonding, and metallic bonding. Bye-bye for now.